Hello everyone. Welcome back to Dr. Lu's VCE Chemistry channel. Today, let's learn together about the 2020 VCE Chemistry examination. We will focus on questions related to spectroscope analysis. This section is one of the most difficult topics in VCE chemistry, another is electrochemistry. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. 2 NH peaks are seen and 1 C equals O peak is seen. I don't think there is any OH peak. So, C is correct. The keywords are region 3100 to 4000. That means that we should focus on the information within this region. This compound contains oxygen, so, may be an alkanol. However, no OH peak is found in this region, so, this compound is not an alcohol. There are 4 carbon and 8 hydrogen. That means the amount of hydrogen is 2 times that of carbon. So, this molecule should contain 1 double bond, 1 carbon-carbon or 1 carbon-oxygen double bond. The CNMR has 4 peaks. Furthermore, it is lack of O. So, this molecule should contain 4 different carbons and 1 carbon-carbon double bond or 1 carbon-oxygen bond, but not O. Please draw 2 structural formulas. The high-resolution 1H NMR spectrum of the unknown compound has 3 single peaks. Identify 3 pieces of information, not write the structure. 3 sets of peaks on the 1H NMR spectrum indicate 3 hydrogen environments. No signal splitting, single peaks, on the 1H NMR spectrum indicates there are no regions in the molecule where H atoms are attached to adjacent C atoms, there are no neighboring H atoms. The peak area ratio 3:3:2 indicates 3 different hydrogen environments containing 3, 3, and 2 hydrogen atoms respectively. The type of environment is indicated by the chemical shift, for example. Analytical methods are often classified as being either classical or instrumental. Classical methods include qualitative analysis and quantitative methods. Instrumental methods include a variety of spectroscopy. Explain how the classical methods can be used to determine information about alcohol. Refer to qualitative analysis and quantitative analysis. Qualitative analysis determines whether a compound is an alcohol and the type of alcohol. Alcohols react with carboxylic acids to produce esters which can be identified by smell. Add acidic permanganate or acidic dichromate to the sample. If the color changes, it is primary or secondary alcohol. If not, it is tertiary alcohol. Quantitative analysis is used to determine the concentration of alcohol. The sample is titrated using a redox titration, or oxidize alcohol to acid and titrate with base. 2 marks were awarded for the qualitative analysis as long as a clear link to an observation could be made, i.e. a color change, a smell, production of bubbles, etc. The keywords are the principles of IR spectroscopy and 1H NMR spectroscopy and different spectra for the ketone and primary alcohol. IR spectroscopy, principle, IR measures the vibrations of atoms in a molecule and can give information about the type of bonds, functional groups, present in a molecule. The OH bond will show a distinct peak between 3200 to 3600 in primary alcohols. The C equals O bond will show a distinct peak between 1680 to 1850 in ketones. So, the different peaks are used to identify ketone and primary alcohol. 1H NMR spectroscopy, principle. 1H NMR measures the change in the spin state of nuclei and can give information about the H environment present in the molecule. Interpretation of spectra. Primary alcohols show a chemical shift of 3.3 to 4.5 parts per million for H atoms adjacent to the O functional group and a singlet between 1 to 6 parts per million for functional group H. Ketones show a chemical shift is 2.1 to 2.7 parts per million for H atoms adjacent to the C equals O functional group. The symmetry of the C3H6O ketone means that there is only one HNMR peak in the spectrum, whereas there are 4 peaks in the spectrum of the C3H6O primary alcohol. 1 mark each was awarded for stating the principle by which 1H-NMR and IR spectroscopy operated. 1 mark each was awarded for stating how the interpretation of the spectra could be used to uniquely identify the 2 isomers. 1 multiple-choice question is worth 1 mark, and 2 short-answer questions are worth 14 marks in spectroscope analysis. The overall score for this section is 15 points. With a total possible score of 120 points, the percentage for this section was 12.5% of the total score.
If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.